through 42 that we assigned?
So far, no.
So far, no. Aaron?
I don't remember exactly what the question was, but it was number 19.
Sure. We can look at that. Number 19 says, two concentric circles are cut by the same angle. The radius of the smaller circle is 4.3 inches, and the cut arc measures 5.2 inches. If the radius of the larger circle is 5.2 inches, what is the length of its cut arc? Round your answer to the 100th. When we say concentric circles, what are we talking about, Aaron?
That's the part I got.
Okay. So it's two circles that share the same center. So it's like one circle just kind of inside of the other, like a bullseye. So, and those two concentric circles cut by the same angle give us two sectors, right? A little sector and then like a big sector. Cool with that? Now, since it's the same angle, the central angle for each sector will be the same. And I'll have like radius for the inner, it tells me is 4.3. And the arc length for that inner is 5.2. And the radius for my outer, it tells me, is 5.2. And we're looking for the arc length for the outer. Oops. So far, so good. So if I look at that bigger sector, you notice I'm missing both the central angle and the arc. So I'm not going to be able to compute. I can't find that arc length until I've found that central angle. The good news is, if I look at the smaller sector, I have both S and R. So I can solve for theta. And after I have that theta, I can just plug it in, and then bloop, into my calculator you go, and out spits an answer. Does that feel okay?
Yeah.
So again, like, you notice I took quite a bit of time at the beginning, like drawing some pictures and making sure I really understood what was going on. And that helps enormously, right? Like draw a picture. This class, in general, trigonometry is a pretty important to be able to draw a picture and be able to draw a good picture out of that, so that helps a bunch. Other questions from homeworks? Yeah, Lucy. 22. Okay. It says two toy racetracks form concentric circles. Each track is divided into 15 identical sections. If the inside car travels 1.2 centimeters less than the outer car on each piece of track, how much bigger is the radius of the outside track compared to the inside track? The hint is to set up two equations using the arc length formula, and then use substitution to solve, round our answer to the 100th. All right, well, we'll start drawing ourselves a picture here. So it's really the same picture as last time, right? We have two concentric circles. I'm just going to draw one of those 15 identical sections. and just kind of draw and label some stuff. So far, so good? Okay. So let's look at what we have here. It says each racetrack is divided into 15 identical sections. So I'm going to have 15 of these sectors, right? If I add up the central angle for all of those sectors, what does that have to equal? 360, because it's going to make a circle, right? So if I take that 360 and I divide it by 15, that'll tell me how many of those little guys that I need, right? So far, so good? Now it's telling us to use the arc length formulas. I'd much rather use the radian version for the arc length formula because it's just S equals R times theta. It doesn't have all that extra gobbledygook in there. So I'm going to convert this into radians. And now I acknowledge that I could reduce that fraction, but this is just going to get plugged in to get an answer later, so I don't need to really reduce it for anything. It's not going to be a final answer. So I'm just going to leave it the way it is rather than like reduce that at all. You know what I'm saying, Luce? Okay. All right. And then it tells us that the inside car travels 1.2 centimeters less than the outer car on each piece of track. Well, that's telling us that SI equals SO minus 1.2. So far, so good? Okay. All right, let's set up our system then. So I know that like SO is equal to RO times theta. SI is equal to RI times theta. That's my system. We know that SI is SO minus 1.2, so let's make that substitution. And I'll also drop in my value for theta, since we figured that out also. Lucy, we doing okay still?
Yep.
Okay. I keep asking because this was your question. Okay. Now let's look at the next part of this question. It says, how much bigger is the radius of the outside track compared to the inside track? So it's asking us for RO minus RI, right? How much bigger is the radius of the outer than the inner? That's RO minus RI. So that's actually what I'm going to solve for. It turns out with the system that we have, I can't actually solve for RO and solve for RI separately. I can just solve for the difference. Because if I look at that system, how many variables do you count in our system down here? I see 3, right? I see SO, I see RO, and I see RI. If I have 2 equations, I can't solve for all 3 variables if I only have 2 equations. But what I can do is I can solve for RO minus RI, and that's what I'm about to do. So what I'm going to do, if I call this guy equation A and this guy equation B, I'm going to do equation A minus equation B. So I'm going to have SO minus 1.2 equals RO times 24 pi over 180 minus RI times 24 pi over 180. Kind of, yeah. Okay, can you be a little bit more specific for me?
Like, I don't understand like, what we're doing.
Okay. Where did we lose you at?
Like, how do I know to, like, I don't know, I just don't understand it.
Okay, and I want to help, but you have to, like, we have to get, were we okay with the picture?
Yeah.
Okay, were we okay with how I found theta? Okay, so it's a circle, right? And we're cutting it up into 15 separate pieces, identical pieces. So if there's 360 degrees total in a circle, each piece is going to be 1/15 of that 360. So I just divided it by 15. Okay? And because the directions told me to use the arc length formula, I opted to use the radian version of that formula because it's a simpler formula. So I converted then that 24 degrees into radians. Right? Because there's two versions of that arc length formula. And I wanted to use the simpler one. It doesn't really matter which one you use, Tia. Either will be okay. I'm just, trying to make it a little bit easier. Did you understand in the green that I've highlighted how I got that SI equals SO minus 1.2? So the green says the inside car that's travels 1.2 centimeters less than the outer car on each piece of track. So the pieces of track on the inside are the SI, and the pieces of the track on the outside are the SOs. So it's saying that SI is 1.2 less than the SO. So I did SI equals SO minus 1.2. Is that okay? In the blue, it says how much bigger is the radius of the outside track compared to the inside track. So the radius on the outside is RO. The radius on the inside is RI. It's asking for the difference between those. So what we're looking for is RO minus RI. Does that feel okay? All right. So what I did then is I followed the hint that it's given me in the problem where it says set up two equations using the arc length formula. So that's what I did there. So SO equals RO times theta, and SI equals RI times theta. It then says, and use substitution to solve. So I substituted in SI for what we know SI is. So that's how I got to there, right? That gets rid of one of my variables. And then I plugged in thetas because I know theta is that. So that's how I wrote that. So far, so good? Okay. So this is all just kind of getting to the setup to solve this thing, which I'm about to do now. So now to solve this, I'm going to use elimination. And the reason I'm electing to use elimination is because I want to find RO minus RI. So I'm going to take the equation with the RO in it and subtract it from the equation with the RI in it. Or subtract from it the equation with the RI in it. And that's what I'm writing here below. So I have left-hand sides minus left-hand side, right-hand side minus right-hand side. And now I'm about to do some simplifying and clean this up a little bit. Did that okay? Okay. So if I look at the left-hand side, I can distribute through that negative. And I can write that. On the left, or on the right-hand side, I notice that I have a greatest common factor of 24 pi over 180. So I'll factor that out front. If I look at that left-hand side, I have SO minus SO. Those just cancel each other out. Yay! And now I just need to get this by itself, right? That's what I'm trying to solve for. So to get that by itself, I'll just multiply by the reciprocal, right? And then it's just calculator time. Lucy.
Yes.
Satisfied.
Yes.
Okay. Now, would I give you something this complicated on a quiz or a test? No. No, I would not ask you to do something this complicated on a quiz or a test. Do I mind giving it to you in homework? No, because it allows us to connect a bunch of ideas from Algebra 2 that we probably haven't used in a while. It serves as a good review. We connect a bunch of ideas we've worked on here. It really tests for some understanding. But something this complicated, I would not ask you to redo. Everybody's okay? Yes, sir.
So just clarifying, you basically took a formula and plugged that into both the outer circle and the inner circles, chopped up these.
The sectors.
And then solved for what was on the outer the ring of that circle.
I solve for the difference between RO and RI.
Which part of RO and RI?
So RO is the radius.
Oh, the
right?
radius. Okay.
So RO and RI from my picture.
Alright.
So that's what I solved for, was how much longer is the outer than the inner.
Okay.
Is that?
Yeah, so I guess that
They're not triangles at all because they're sectors, right? They're pizza slices.
Mr. Coolid,
Yeah,
what does azimuth again?
arc length.
Arc length.
So it's like part of the perimeter of a circle.
Because A is area.
A, capital A, usually we use for area, sure. Okay. Any other homework questions?
I'll come to you.
Okay. Today, we're going to do section 2.3. This is a slight adjustment from what I originally had posted to My Notre Dame, where we were going to do 2.3 and 2.4. I rethought that a little bit after I looked closer at what we're doing. 2.3 is kind of an important section because it's a skill that if we don't have this skill, almost everything we're going to do in the future, in the next coming weeks, is going to be a problem. So this is a really important sub-skill that's necessary to be able to do much in the future. So I want to make sure we do a good job here. So we're just going to do 2.3 today. Everybody cool with the plan? All right. So recall from geometry. When we draw an angle and we talk about the size of an angle, we're always talking about that part, right? We never are talking about that part. Everybody's okay there? That sound familiar?
Yeah.
Which means in geometry, the biggest angle we can draw is 180 degrees, right? We always look at the smaller part of an angle. The biggest thing we can draw is 180 degrees. Everybody cool? What we're going to do today is create a new system of drawing angles that will allow us to draw angles of any real numbered value. So you can draw them as big as you want. Can be bigger than 180, could be bigger than 360, could be as big as you want, or as small as you want. They can be negative values now as well. Okay? So let me show you how we're going to do this drawing. The trick here is that we're going to embed our angle into the XY axis. So we'll start by kind of drawing our XY axis. And we're going to fix the vertex of our angle to the origin of the XY axis.
Waiting.
You guys got this figured out?
Yeah, I was just getting the bottom.
We're going to draw one arm of our angle always on the positive x-axis. We call this arm the initial side. And the other arm, we're going to rotate about the origin. So if I want to draw a 190 degree angle, remember this is an angle that I could not draw in geometry class. I'm going to rotate now my other arm starting at the initial side, counterclockwise. And just as a reminder here, folks, how many degrees are in each quadrant? 90 degrees. Everybody look at that and be like, oh, of course. Of course, sure. Okay, so starting here at the initial side, I go 90 degrees, 180 degrees, and then like 10 degrees more. I'm just kind of eyeballing the 10 degrees. 190 degree angle. Everybody feel okay there? Now you should be thinking, okay, Mr. Kulik, fine, but you just said there's only 90 degrees per quadrant. How am I going to draw something that's bigger than 360? Well, let me show you. Let's do a 510. So I'll redraw my XY axis, place my vertex at the origin, draw my initial side. Ooh, time out real quick, piece of vocab. This other arm of my angle is called the terminal side. So we have the initial side, initial start, terminal side, terminal's end. So far, so good? Okay, we're going to draw a 510 degree angle. Starting at the initial side, 90, 180, 270, 360, 450, and no, 450, and then like 60 degrees more. And there's our 510. So we just keep going around in a circle, right? Like if we look at a clock and I ask, where's that minute hand going to be? You know, like 100 minutes from now? Well, there's not 100 minutes on the clock face. You just do 60, and then you do 40 more, right? Same idea, just like a clock. An analog clock, not your digital clock. Tia. Sure. So far, so good? Fairly simple so far, right? Really important, though, that we're able to draw these pictures accurately. Now, you should be saying, okay, Mr. Kulik, I see how I can draw an angle as big as you want. I just keep going and going and going until I get there. Fine. Okay, no big deal. But you also said I could draw it as small as I want. How do I draw a negative angle? You just start going the opposite direction. Exactly right. So let's say we did negative 240 degrees. So we'll draw our XY axis, vertex at the origin, initial side on the positive x-axis. And because this is a negative angle, we're going to rotate clockwise. So negative 90, negative 180, and then like 60 more. And that'll be negative 240. Is everybody okay with that?
Yeah.
Okay. So far, so good. No big deal. What I would like for you guys to do for me next is I would like you to draw a yeah, let's just keep it simple. So on your own paper, draw a 45-degree angle and a 405-degree angle, and do them on the same XY axis. So take a minute here. I would like everybody to try this on their own sheet of paper, to draw a 45-degree angle and a 405-degree angle on the same XY axis.
Mr. Cooler, I was in here last class, for 1 to 42, where was that from Europe or from Delaware?
It's in the OneNote.
Okay, one.
So if you look at the problems, will you see,
Yeah. Chapter.
there they are.
Okay.
Okay? Sure.
And then will those automatically save and you'll look at them, or do we have to like screenshot it?
We'll talk about how to get it into your OneNote here in a minute. Okay? Sure. You should be trying to draw these two angles right now. Mm-hmm. So there's my 45. And then my 405, I did 90, 180, 270, 360. And then 45 more would be here. What do you notice? Well, they're not the same. They have different angle measures. But what is the same?
The angle in its exact segment.
The location of the terminal side is the same,
Yes.
right? That piece that rotated around, the terminal side is in the same location.
Wouldn't it still be a 405-degree angle though if you started on the left though, right? Not on the other side?
No.
Oh, it'd be negative 45.
Yeah.
Okay.
Okay.
I got
So back corner, Tommy, Maggie, Aiden, Gavin, you guys need to cool it on talking. Like every time I take a pause, it's like you guys fill up all the empty sound, and I need you to stop. Okay? Thank you. Okay. So this is a special occurrence when you have two angles that are different measures, but their terminal sides are in the same location. We're going to give this a name. This is a definition. We're going to call these angles coterminal angles. Okay, so angles that have different measurements, but their terminal sides are the same. Those are coterminal angles. Now look at these two particular coterminal angles we have, 45 and 405. What's the gap between those two angles? 360 degrees. Does that make sense?
Yeah.
If I have an angle and I go 360 degrees, where am I going to end up at? Exactly the same spot I started, right? So to find coterminal angles, we just take an angle and we keep adding or subtracting 360. Each time we do that, we're going to get a new coterminal angle. How many times could I add 360 to a number?
Infinite.
Infinitely many. So how many coterminal angles are we going to have? Infinitely many as well. So in the homework, if we ask you for coterminal angles, how many answers could there be? Infinitely many. If you look at the answers, am I going to list infinitely many? No, I'll probably just list a couple. Okay? But you could make infinitely many of them if you so chose. Let's do a quick example. So part A says find two angles coterminal with 47 degrees. Okay, so if I want to do that, I can take 47 degrees and just add 360 to that to get 407. To get a second coterminal angle, I can just take the 407 and then add 360 again. That'll give me 767. Could I add 360 again and get another one? Sure. Could I have started by subtracting 360? Sure. Could have I subtracted 360 from 47, then added 360 to 47? Yeah, there's lots of ways you could do that, right? Is everybody okay? Let's look at part B, though. It says find two angles coterminal with pi over 3. The heck is that? It's just an angle in radians. So, quick question for you guys. I have an angle in radians. Can I add an angle in degrees to that? No, why not? The units are different.
Yeah.
So to add them together, they have to be the same unit, right? Aiden? Sure. So let's convert 360 to radians, and then we'll add that equivalent angle in radians to pi over 3. So we'll start there. So to convert degrees to radians, we multiply by pi over 180. That gives me 2 pi. That would be a good relationship to remember, that 360 degrees is the same as 2 pi. That'll come up a bunch of times in a bunch of different places. That's something that you probably want to remember. But that's all I need now to be able to do my coterminals. So I'm going to take my angle, pi over 3, and I'm going to add the radian equivalent of 360 to it, which is just 2 pi. Now, to add pi over 3 and 2 pi, what do I have to have?
Same denominator.
Common denominator. Very good. What would the common denominator be? 3. So I'm going to think about 2 pi as 2 pi over 1. I'll multiply the top and bottom by 3 over 3. So what I really want to do is pi over 3 plus 6 pi over 3. What do I get when I add those two together? 7 pi over 3. So to get my second angle, I'll start with my 7 pi over 3. I'll add 2 pi again, but I already know that I'm going to need to make a common denominator, so I'll just write 2 pi as 6 pi over 3 this time since I already did it once. And when I add those together, I get 13 pi over 3. Is everybody okay with what I did here? Okay. Now, how many of us have low fractions confidence? Low confidence that I can accurately deal with fractions. All right, so let's show you how we can use our calculator to help us in this. Yes, sure. Okay, so your calculator, if you put anything with pi in it, you're only going to get back a decimal. So I can't press pi over 3 plus 2 pi into my calculator and get anything other than a decimal. However, if I just leave off the pi's, I can write into my calculator 1/3 plus 2, get the fraction, and just write the pi in at myself when I write down my answer. That the calculator can do. So let's show you how to do that. So I'm going to start by pressing alpha and the y equals button. I'm going to select option 1. That'll give me the horizontal fraction bar. Ava, I think your calculator's operating system is older than it doesn't have this capability. So you're going to be stuck doing it by hand. Or you have another newer one? Okay. And Isabel, we talked about this already, right? And you're welcome to borrow one in the case that you want one. Okay, so I'm going to do 1/3, and I'm going to write plus 2. That's the same problem that we started with. I just left the pi's off, right? I press enter. 7/3 pops out. Beautiful. If I wanted to do 7 pi over 3 plus 2, I'm just going to do the same, or plus 2 pi. I'm going to just drop the pi's again, so 7/3 plus 2. 13 over 3, I just stick my pi back on, 13 pi over 3, and I'm done. Very nice tool to have if we have low fraction confidence. The calculator can handle this for us. That's pretty nice. Everybody okay with how to do that?
Yeah.
Okay. All right. Yes, Colby.
I got 1/6 for like the first one before you did.
That's because your plus 2 is in the denominator.
No, I didn't do the plus 2.
Let me see it.
I didn't get 7.
Let me see it. To find it.
It's 1/3 divided by 2.
No, that's a plus.
2.
Alright.
Sure. Oh my goodness. All right. So this is all I need, all we're going to do for section 2.3. So for section 2.3, we're going to have a new Delta Math assignment. Okay. So if you go to your Delta Math, you'll see chapter 2, Delta Math number 2. There's 4 types of problems you're going to have to do here. Let me show you how to do these. So the first one is about estimate the value. So it says estimate the given rotation within 10 degrees. So let's look here. So here to here is 90. And that looks like halfway into the next quadrant. So that's another 45. So I would guess this is about 135. 90 to here, and then 45 to there. I know it's 45 because it looks like it's halfway. And I'll say that's my guess. It says good. It says the actual value is 140, but ours was close enough. Everybody's okay? If you're not within 10 degrees, it just makes you do it again. no big deal. Next one is we're going to do some angle of rotations. So we're going to rotate. So to do this, I'm going to see the yellow circle here. I'm going to left click with my mouse and I'm going to rotate. Here it says 15 degrees. So that looks like about a third of the way maybe there. So that's probably 30 degrees. I'll do like half of that. And maybe there. Submit my answer. Says okay. Mine was actually 13 degrees, but again, as long as you're within 10 degrees, it'll take it, right? It has some with large angles, so 658. So again, I'm going to do this the same way. I'm going to grab this and hold on. 90, 180, 270, 360, 450, 540, 630, and now I need about 28 degrees more, probably in that neck of the woods. Said good enough. I did 662, but it was within 10 degrees of 658, so I'm good. Does everybody feel okay doing this so far?
Is that what we're going to be doing today?
Yep, these are the delta mass. And then the last one is finding coterminal angles. So here it wants an angle coterminal to 550, but it requires it to be between 0 and 360. So for that 550, should I be adding 360 to it or subtracting 360? Subtracting, because 550 is bigger than 360. So I'll just take my calculator, 550, and now I'll minus 360. 190 is between 0 and 360, so that should work. Type in 190, submit. That's good. These are the 4 types of delta math problems you're going to have to do. Pretty realistic to finish this inside of the class period. So that's one part of your 2-3 assignment. The other part is for not this, Monday's homework check, but the following Sunday's homework check. We're going to start by assigning problems 43 and 44. Okay with that? So Monday by midnight is due 1 through 42 from the problems and this delta math. Next week, Sunday at midnight, so far all that's due is 43 through 44, but we'll pick up some more homework next week in class as we do more stuff.
Okay.
Is everybody okay there? Okay. The last thing I want to do before I let you guys go to work is I want to talk about how we get an assignment from our notebook into our OneNote and what is some of the easiest way to do that. Okay? If you have your completed 1 through 42, you can take that out and we'll walk through the process and you can do that on your completed 1 through 42. If you have just a page that you're ready to put in, we can do the page. If you don't have anything done that you're ready to put in, you can just find some googly-gog page of your notebook and do it as a sample, right? Everybody's okay? The easiest way to do this is if you have an iPhone, to take out your phone. I'm allowing you to do this right now. I'm asking you to take out your phone if you'd like to follow along. If you have an iPhone, my directions will make sense. If you don't, just take pictures and it'll be fine. So with your iPhone, open up the Notes app. So the yellow Notes app. From the Notes app, open a new note from your iCloud folder. So if you pay the extra 99 cents a month or whatever to have the expanded memory because your iPhone backup never is complete because you have too much on your phone and they do it intentionally, so you have to buy something else to be able to back up your phone properly. You have to have that. So from your iCloud, you open up a new note. Just click somewhere on the note. That brings up the keyboard. Above the keyboard is a little picture of the camera. Right above, like in the middle, above the keyboard is a little picture of a camera. Touch that and pick Scan Documents. Scan text, sure. Yep. And you just hold it over and it'll boop, take a picture, and you can keep turning pages and taking new pictures. I think it's supposed to be Scan Document though, Tommy. Not Scan Text. If you scan text, I think it'll try to take your words and put them into the note. I don't think you want that. You want the whole image. Once you've got all the pages you need, back out of that note into the file and email that file to yourself.
Or are we just turning stuff into PDFs?
That's all this is doing right now is it's turning it into a PDF. Yup. Yes, but it's already on your phone too, dude.
Yeah.
So once you've taken that PDF and emailed it to yourself, this is some kid that emailed me a homework assignment. So you have your email to yourself. You'll click on your PDF. You'll click on Print, and it opens a new window. I hate that it does this. It can't just let me print from here. I'll click Print, and from this destination, you'll pick OneNote Desktop. You might have to click See More to find it, but you pick OneNote Desktop and then hit Print. What that does is if OneNote isn't already open, it'll open it and it'll give you a prompt. It'll say, where do I print this to? So you go down to your 8th hour notebook, and then maybe Aiden, I'm going to use yours for a demonstration. You click your name, you pick the homework folder, and you hit OK, and boom, drops that PDF right in. It's all in there, nice and beautiful, all the pages, all in one shot. If you had to take pictures and email them to yourself, and you're emailing pictures, you'd have to do like one picture at a time. That's why I like to use the notes to capture the PDF, because it gets it all in one shot. It's a little bit quicker. Any questions on what I did there, Jamie?
When we're doing like the delta math, do we have to like take any pictures or like write anything in our notebook to show you, or will you just know that we did it?
I will just know that you did it. You need to give me nothing for the delta maths. That's all the information I need. The delta math gives me, tells me what you did and what you didn't do and what you've done and not done. It's very clear for me. So I don't need anything from you for delta maths. Good question though. Okay. The remainder of this class you can be working on. If you haven't finished your 1 through 42, you could work on that. If you want to start your 43 and 44, you could work on that. If you need to do that, or you want to start this new delta math, you can do that. Based on the previous hours, shouldn't be a problem if you're working the whole time to finish the entire delta math. That should be no big deal. That might be where I would recommend starting, since that's due Monday at midnight along with the 1 through 42.
Let's do one day at midnight.
Monday, because we don't have school on Monday.
Oh, perfect.
So you get an extra day this week. Yes. Go ahead. Yeah.